Hello, everyone. Today we are going to continue our discussion of conic sections, and we will do the parabola. If just to remind you of what we said earlier is we may have a lot of um, terms that look something like that. And this is basically for any conic section plus dx plus ey plus f equals 0. And we said we are not going to consider the case of xy, meaning b is 0 always. When b doesn't equal 0, meaning if I have a cross term, then I'm rotating one of the conic sections, okay? You can write xy equals something and you get a parabola, for example, but that's not what we are going to do now. I'm going to address that later when we discuss rotation and reflection over any line or through any angle in an advanced session. But for now, we said if A and C have the same sign and the same magnitude, that's a circle. If both have the same sign but not the same magnitude, it's an ellipse. That's what we did last time. Now, if one of these two is 0, that becomes a parabola. And the last one that we will address next session is if both of these have different signs, whether they are equal or not, that's not the issue, but if they have different signs, that's a hyperbola. Now, the way we are going to show our parabola would be one of different forms. So for example, I can have y equals some constant, let's say we call it for now a, times x minus h squared plus k. That's usually how you will see it. I prefer to move the k to the left-hand side so it would remind you of what we did when we addressed graphing functions. Remember when we had a parent function and an altered function, and then we looked from the point of view of algebra, how we can find exactly what happened to the parent function to become the new function. So that's why I prefer to do it this way. You don't have to do it this way, but I'm going to write it in this form. Now, this letter A is basically equal to 1 over 4p, where p here is the distance from the vertex to the focus, or from the distance from the vertex to the directrix. So let's take it one step at a time. If I have a parabola that looks like that, it means my axis of symmetry is parallel to the y-axis, always parallel to the one that is linear, not square. So I know my axis of symmetry is vertical, and my parabola, if 1 over 4p is positive, it's opening up. If it's negative, then it's opening down. So assuming it's positive and it's opening up, my parabola would look something like that. This point is h and p. I was going to write x and y. I'm sorry. H and k. And then we say that the parabola is the set of all points. Any point on the parabola is equidistant, meaning it has the same distance to a point called the focus and to a line called the directrix. So if the focus is above, like in this case, the directrix would be below. If the focus is below, meaning if the parabola is opening down, then the directrix would be above. If it's opening to the right, the directrix would be to the left. If it's opening to the left, the directrix would be to the right. So it's not drawn to scale, of course, but if that was a true parabola, these two distances would be equal. Now, by the same token, that distance is the same as that. So that's the P, and that's the P. So if this point is H and K, then this point would be H and K plus P. And how do I get P? Well, P is 4 times what this number, 1 over, or the reciprocal of that. And that's why sometimes we prefer to write it in a different way. You'd multiply both sides by 4p and you get x minus h squared equals 4p times y minus k. And in that case, this number right there, you just divide it by 4 instead of taking the reciprocal and then divide by 4. Or instead of multiplying by 4 and then take the reciprocal. Anyway, so basically, if I have my, so let's take another one. Let's say it's opening to the left. So now the x would be the linear and the y would be the square. So I would have y minus k square equals something times x minus h, but that something has to be negative. So if I say 4p, here 4p is less than 0. And here, in this case, 4p is greater than 0. So if it's negative, it's opening to the left. If it's positive, it's opening to the right. And the axis of symmetry is parallel to the x-axis. If the y-axis is the axis of symmetry, then positive 4p is opening up, negative 4p is opening down. And here that would be the vertex, and here would be the directrix. We'll take an example to see how we find those, but that's basically what we are going to cover today. One last thing maybe we didn't mention in ellipse, and we will mention it here, is that if you take a line parallel to the directrix and passing through the focus, that distance, let's call these, I use the letter A, so let's call it BC, for example. BC here is referred to as the latus rectum. And the BC here, if that distance we said it's P, and if this is 4P, then the distance from here to here or from here to here would be 4P. Meaning this distance would be, oh, I'm sorry, to 4P. This is 2P and this is 2P. Okay? So let's take an example or two examples, one for vertical, one for horizontal. So let's say the first one, they tell you x squared minus 8y plus 12 minus 4x equals 0. So the first thing, I want to put it in this form. So I'm going to leave the x components only on the left and move everything else to the right. So I have x squared, I have negative 4x. So I'm going to open parentheses because here I have to complete the square, as you know. So I'm going to say x squared minus 4x and then leave a blank and then say equals 8y minus 12. And then I complete the square, and we learned how to do that last time. I divide the coefficient of x by 2, I get negative 2, and then I square it, it becomes plus 4. And since I added 4 to the left-hand side, I have to add 4 to the right-hand side. The left-hand side becomes x minus 2 squared. We already, when we divide this by 2, you got negative 2, so you know this is x minus 2 squared equals 8y minus 8. I can factor the 8 out, and that would be y minus 1. And you can see now the following. First of all, the axis of symmetry is the y. So, and here it's a positive number. So it's opening up. Okay, the parabola is opening up. This point is 2 and 1. 4p equals 8, so p equals 2. 2 units above that. So it's really 2 and 3, the focus. 2 units below the vertex is my directrix. Notice the equation, that's a horizontal line, so its equation is y equals 1 minus 2 is negative 1. If you want to find the lattice rectum, we know that this distance is 4p, meaning this is 2p and this is 2p. If p is 2, then you go 2p to the left, meaning 4 to the left. This point would be negative 2 and 3. And if you go 2p or 4 to the right, that point would be 6 and 3. That's if they ask you to find it. But that's how easy you can do it. Let's take another example for a parabola that's opening sideways or horizontally. So let's write down another equation. Let's say negative x plus 2y square plus, let's make that 16. And if this is 16, oh yeah, I had to use this to remind you of something we did last time. I didn't use 1 here for a purpose. Okay. So now you can see that the square part is y, so that's what I leave on the left-hand side, and everything else would move to the right-hand side. So I'm going to say 2y squared plus 12y equals x minus 16, right? By moving the x and the 16 to the other side. I see a 2 here that I can factor out. So I'm going to write y squared plus 6y. I'm going to leave a blank equals x minus 16. So like what we did last time, I'm going to look at the coefficient of y, which is 6. I'm going to divide it by 2. It becomes 2. And then I square it, so it becomes 9. I'm going to add 9. And please be careful. I'm not going to add 9 to the left-hand side because I didn't add 9. I added 18. If you factor something out, be careful to include it later, because that's a common mistake I see students do. Say, oh, I added 9 here, so I'm going to add 9 there. You didn't add 9. You added 18. 2 times 9. So you have to add 18. And finally, this can be written as y plus 3 square equals x plus 2. And then I had a 2 here. Notice I wanted to look like I wanted to have 4p on the right-hand side. So the left-hand side, there is nothing multiplied by this pair of parentheses. Y plus 3 squared has to be by itself. So I have to divide everything by 2, and you get 1/2 times x plus 2. Right there, it tells you the x-axis or the axis of symmetry is parallel to the x-axis. And because this is positive, my parabola is opening to the right. Okay? Now, this is the axis of symmetry, and the vertex here is -2, -3. 4p equals 1/2, so p equals 1/8. Okay? So if it's 1/8 along the x, this is negative 16/8. So if you add 1/8 to it, it becomes negative 15/8 and -3. And the directrix would be at negative 17/8 and negative 3. And if you want to find the lattice rectum, that distance is 1/8 above and 1/8. I'm sorry, 4p. So it's 1/2 above, and it's the whole distance is 1/2. So you take a quarter above and a quarter below. So that would be negative 15/8. If you add a quarter, then you get negative 11 fourth. And if you subtract a quarter, you get negative 15/8 and negative 13 fourth. And that will be it. So now we learned how to to draw a parabola if given its equation, or sometimes even you can be, I don't think they will give you that. Yeah, they may tell you, okay, here's a parabola. The vertex say is at 2 and 1, and the axis of symmetry say is vertical or something, and they give you an extra piece of information and you can find out the equation. But other than that, basically that's all what you have with parabolas. And again, as usual, I say if you have any questions, please add it to the comment section. If you need more examples, I may have another session to cover more examples if these two are not enough for you. But just let me know what you need and I will comply. Thank you very much and hope to see you soon.